In 1996, a British Airways plane flew from New York to London in a record-breaking 2 hours and 53 minutes. Today, however, passengers flying the same route can expect to spend no less than 6 hours in the air, twice as long. So why, in a world where everything seems to be getting faster, have commercial flights lagged behind? The British and French-made Concorde began shuttling passengers across the sky in the 1970s. Jetting between destinations like New York, Paris, Bahrain, and Singapore, it clocked in at over 2,000 kilometers per hour, more than twice the speed of a normal airliner. However, this was also about 800 kilometers per hour faster than the speed of sound, and that created a surprising problem for people on the ground. When an object moves at supersonic speed, it generates a continuous moving shockwave known as a sonic boom. This produces a loud, startling noise, as well as rattling windows and dislodging structural elements of buildings. Since a plane flying at an altitude of 15 kilometers can affect an area with an 80-kilometer diameter on the ground below, complaints and concerns from residents in the Concorde's flight path restricted it to mostly ocean routes. Because of these restrictions and other fuel and engineering requirements, supersonic flights turned out to be very expensive for both airlines and passengers. A single transatlantic round trip could cost the equivalent of more than $10,000 today. With additional strain on the airline industry due to decreased demand for flights after September 11, 2001, this became unsustainable, and the Concorde was retired in 2003. So even when superfast flights existed, they weren't standard commercial flights. And while we might think that advances in flight technology would make fast flights less expensive, this hasn't necessarily been the case. One of the biggest concerns is fuel economy. Over the decades, jet engines have become a lot more efficient, taking in more air and achieving more thrust, traveling further for every liter of fuel. But this efficiency is only achieved at speeds of up to around 900 kilometers per hour, less than half the speed of the Concorde. Going any faster would increase air intake and burn more fuel per kilometer flown. A standard transatlantic flight still uses as much as 150,000 liters of fuel, amounting to over 20% of an airline's total expenses. So any reduction in fuel economy and increase in speed would significantly increase both flight costs and environmental impact. What about ways to make a plane faster without burning lots of fuel? Adjusting the wing sweep, or the angle at which wings protrude from the fuselage, to bring the wings closer in can make an aircraft faster by reducing aerodynamic drag. But this means the wings must be longer to achieve the same wingspan. And that means more materials and more weight, which in turn means burning more fuel. So while airplanes could be designed to be more aerodynamic, this would make them more expensive. And generally, airlines have found that customer demand for faster flights is not sufficient to cover these costs. So while military aircraft conduct high-speed flights over water and at high altitudes, supersonic commercial flights seemed like a brief and failed experiment. But recent advances may make them feasible again. Research by NASA and DARPA has shown that modifying an aircraft's shape can reduce the impact of its sonic boom by 1/3. Extending the nose with a long spike can break the shockwave into smaller ones, while another proposed design features 2 sets of wings, producing waves that cancel each other out. And new technologies may solve the energy efficiency problem with alternative and synthetic fuels, or even hybrid electric planes. It may yet turn out that the last few decades of steady flying were just a brief rest stop.